Welcome to part 7 of the guitar pick trace series. We're going to go ahead and jump into operation 2. So to do that, I'm going to click on my setup. Fusion 360 will automatically adjust the view. And as you can see from the green stock, Fusion 360 is smart enough to bring over our model with the stock left for Op 2. Okay, I'm just going to orbit over here and go to the left-hand view because I want to emphasize that our work origin, or our probe point in my case, because I'm using the Tormach passive probe, is going to be on the fixed jaw side of our vise, and we are going to probe our soft jaw. I'm using the back left corner. You could use the inside quarter if you want. So we're going to probe first and then put our part in the vise and tighten it down. Okay, so now let's go back to our home view. And what we're going to do now is select a 3D adaptive clearing, and we are going to try to remove most of the material that is left over. So you can see this large chunk of material that's usually referred to as a hat on top of our part, so we want to remove that hat material. So again, I'm going to go to 3D adaptive clearing. I'm going to select the tool by going to my local Tormach library. We are going to be using the Gorilla chip breaker again. That's a 3/8 tool, 3 flutes with chip breakers, so that our chips, when we're roughing, are finer. That means you won't get chip buildup. The flood coolant will push it away. And it also relieves some tool pressure so we can move faster than if we were using an end mill that didn't have those chip breakers. So I'm going to go ahead and select that. Our speeds and feeds, so we are running at 7,500 RPM, 60 inches a minute with 2.6 thou per tooth. Because we are using a 3D toolpath, Fusion 360 again takes our geometry into consideration, so we are going to jump over the geometry tab and go to heights. Now we are on the back, so we do have our stock above our part, so we want to make sure that our top heights are still set to stock top. However, our bottom height is wrong. It's set to model bottom. And again, we have to remember here, our part has been flipped over, so our model top is now the back. So we want to go ahead and select model top instead of model bottom, and you'll see the blue rectangle moved up to match that. The next thing I'm going to do is, because on my first 3D adaptive toolpath I removed an extra 50 thousandths. So I'm going to go ahead and match that here. Sorry, minus 0.05. All right. And then we are going to go into our passes tab. And again, our optimal load is the main concern here. For my Tormach, 150 thou is way too much. My rule of thumb, because I am moving so fast, is around 10% the diameter of the tool. I'm going to use 8%, which is 30 thousandths. The next important fact here is I am leaving axial and radial stock. So what I don't want to do is touch any finished surface, so mainly the walls here that our soft jaws are holding. I do not want to touch that because it will leave tool marks and essentially ruin our surface finish. So we want to make sure that we leave some stock on the side wall here so that our end mill doesn't touch it. But because we took off that extra 50 thou, there isn't going to be any stock there to worry about removing anyway. And we are leaving stock on the floor, or what would be this large flat surface, so we can come through on the next operation and face that off and get a pretty surface finish. All right. And I believe that is everything. Again, always check your stay down level. It's defaults to least, so that will reduce any retractions and save us time. So we'll go ahead and click OK. And that should generate our toolpath for us. Beautiful. So we'll right click and we will go ahead and simulate that. Hopefully it doesn't go too fast on us. Nope. And so as you can see, we are just walking around the outside of that top hat and removing the material. I'll speed it up a little bit. You can see the contour of the guitar starting to come into shape. I'll move forward here. Again, the roughing or the adaptive clearing strategy is what normally takes the longest time because we are removing so much material. There you go. That is what the finished toolpath looks like.